So yesterday we went through as a class a whole bunch of the pre-lab stuff to do with the problem, the design, the hypothesis. Okay, and you probably are still going to want to, add a few things to that or tweak it or whatever, and that's fine. You have the rest of class today to work on the pre-lab part of this lab, but that's also going to include writing the procedure, right? And that's going to take you a while because it needs to be a numbered list of many steps, okay, that tell people how to perform this lab in explicit detail. Okay? Do not assume somebody will be able to do it right if you don't tell them. All right? And by that I mean tell them everything. That includes tell them what to look for, tell them what to record, okay? Tell them what observations to make. All of that is part of the procedure. All right? So we already know that we're only performing 4 tests. Okay? The 4 tests we've already talked about are, we're going to have an observable properties test where we look for things like color, state of matters, etc. Okay? We're going to have a solubility test. We're going to have an aqueous conductivity test and a pH test. But if my procedure just says perform observable properties test, somebody's going to go, okay, it's blue. And that's all they're going to write, because you don't tell them what to look for in the observable properties test. You need to be specific and detailed, okay, when you're telling them in an observable properties test, look for the following things. Make these observations. These are the things that should be noted. Okay? Explain that to them so that they know what to look for. Does everyone kind of follow what I mean there? Okay? We also have to include the really stupid simple stuff. Like when you go into the lab, put on safety goggles. Okay? All of that stuff is included in the procedure. Okay? So a couple of things for you to kind of make note of while you're writing up this procedure. The safety goggles are in the drawers of the lab station, the top drawer of the lab stations. Okay? We need to tell people how much of everything to put in their depression plate. Take it easy on the equipment, please. Okay? Tell them how much water to add, what to look for in the solubility test, what kind of things are we measuring, okay? Because lots of times if you just say perform solubility test, somebody just dump a bunch of water in there, right? They may not stir it up, they may not remember to, they may not know to take the temperature, which is an important observation to make. All of that stuff needs to be told to them and explained, again, in explicit detail. Your procedure is going to be at least a page if you do a good job of it. Okay? That's still a numbered list, but a page if you're doing a good job of explaining each and every step. Okay? Now, how many times am I going to be doing the observable properties test and all these other tests? 12. Do I need to write them out 12 times? No. I've had people do that. They're like, take sample A and blah, 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 and then they like copy and paste it 12 times. Which, hey, that's thorough. I'll give you that. But there's zero need to do that. And it makes the lab report like 20 pages long, and 18 of those pages are the same thing, right? So we don't need to do that. We can talk about the tests and how to perform them, and then when we get to the bottom of the pH test, we can say repeat steps, whatever through whatever, for each unknown compound. That's not cheating, that's not being lazy, that's the way you would actually write. Do they want to follow on that? Okay. When you're describing the materials that we're using, okay, as we said before, okay, you want to make sure that you tell them how much to put in. Okay, so what did we say was a good amount yesterday?
Filling up the bottom, like just covering the bottom.
Just covering the bottom. If it's a solid, just covering the bottom. There are going to be 1 or 2 exceptions to that, and I'll tell you what they are on Monday. Okay, but for the most part, solids, just cover the bottom. If it's a liquid, fill it about 1/3 of the way out. Okay, so if it's a liquid sample, about 1/3 of the way. How much water should I add? Like for a solubility test? Should I fill it right to the top? If I fill it right to the top, what'll happen when I stir? It'll spill out and contaminate the ones beside it. That's a big worry, okay? Accidental contamination is one of the big sources of it. Oops. In this lab. I gave something over there. I don't know what we call it. That's okay. All right, we have to be careful about accidental contamination. Okay, we want to make sure that we're getting the material in just the depression that it's supposed to be in. That's also true for the samples at the front of the room. Every sample is going to have its own dispensing tool. All right, so if it's a solid, it'll have a lab scoop. If it's a liquid, it'll have an eyedropper. Okay? If you take something and you take it back to your station and you put it in and you come back to the front, you're like, oh crap, I don't remember which one I took it out of. Just tell me. I'm not going to make fun of you, okay? I need to know so you don't stick the dispenser from A into C and cause a reaction in my samples. Because then the samples are shot, if I even notice that it's happened, okay? And I have to redo them. If I don't notice that it's happened, everybody uses a contaminated sample. And everybody gets bad data, right? So if it happens, it's okay. It does happen. Just let me know, and I'll just clean it off and figure out which one it came from. Okay, but you gotta let me know that. And you gotta be careful with your samples. Okay? If you notice that you're adding some of this and one or two crystals drop into the sample beside it, that's done. You're gonna have to do that one over. Okay? Everybody with me there? Alright, don't go, it's only like 2. Nope, it's done. Right? Do it over. It doesn't take that much time to just go and get that sample again. Okay? But it will really mess up your results if you don't. Another thing about sources of error. A source of error has to be something inherent to the procedure. It can't be a mistake you made. Okay? Human error is not a source of error. So I have people who often do this. They're like, yeah, I contaminated sample B with sample C. And so the results for sample C are inaccurate. And my response to that is, well, I'll just go right back to your analysis, Mark, and take that down a few pegs, because basically what you said to me was, I screwed up, and I was too darn lazy to do anything about it. Okay? That's not how you want me to end your lab marking. Okay? Is to look at your lab report and have you say, yeah, I know I messed this up, but I did nothing about it. Okay? That's not a source of error. Okay? That's you totally screwed it up and didn't do anything about it. So never do that. B, never say that you did it either. Okay? You never want to say, I screwed up and didn't do anything. Okay? Don't do that. All right. So all these little things, all the little things that you might not even think of, are important details that need to be in your procedure. Okay? Where do you go to get all of your stuff? Okay? So when you go into the lab, all of the materials will be on a cart. That is, all of these materials, all the samples will be on the front desk. All the materials will be on a cart. Okay? That's important for your procedure. Go to the front of the room, go to the cart, get this, this, and this. Okay? That's part of your procedure. When you have finished the solubility test, what do you need to do with the thermometer and the stirring rod? Rinse them with distilled water from the wash bottle. All important details that I'll be looking for when I mark your procedure. Okay? Same with the conductivity test. It's got to be rinsed, not dried, just rinsed. Okay? With distilled water. When the whole lab is over, what do you need to do with all of your equipment? Clean it. Okay? That can be done with like soapy water. Okay? Dry it off with a paper towel, that's fine. Right? And where does all the waste go?
I don't want to say where.
No. That is the last place I wanted to go, is down the sink. Okay, in the fume hood, okay, at the front of the room, are 2 buckets. We call them the disgust buckets. disgusting. Okay? They are full of all the chemical waste from every lab we do. All of your stuff needs to be rinsed into there. So you take your depression plate up to the bucket with your wash bottle, turn it over so it all comes out, give it a spray off, turn it over, okay? Then you can take it back to your station and clean it off. As long as the bulk of the stuff has gotten in the waste bucket, the small amount that might still be there that goes down your sink is not a big deal. Okay, but the big samples, that all needs to go in the waste bucket. That's another important part of the procedure, is your waste bin. Okay? Are there lots of little details you probably wouldn't have thought to put in there? Okay, and they're all important, so make sure they're all in there. And again, when you're talking about the tests, be detailed. Explain in detail how to perform the tests. Probably the simplest test to describe is the conductivity test. Okay, I mean the conductivity test involves putting this in the solution you made in the solubility test, pressing the button and recording the number on the face. This is not one that needs a lot of description. Okay, it's pretty foolproof. But the observable properties test, that requires a lot of description. That requires a lot of instruction. Here's what to look for. Here's what to record. And be sure to look for the following things. Solubility test, same thing. When do you take the temperature in the solubility test? What does dissolving look like? What does not dissolving look like? Okay, all of those things are going to be important. Okay, making sense? If you got questions as you go, don't be afraid to ask. But you got the rest of class. You can work with the procedure with a partner or with your group. That's fine. Okay, if the procedures are similar on people's lab reports, I'm okay with that. But your lab report does need to be unique to you. Right? I don't want to be going through two people's labs and have them be exactly the same. Okay? You come up with a hypothesis, it's your hypothesis. Right? Is it similar to your partner's? Okay, maybe, right? But it can't be exactly the same. Right? Everybody is handing in their own lab report. It's not a collaborative thing. And like I said, if your procedures are identical, that I'm okay with. You're coming up with that together, that part fine. Okay? But everything else in the lab report, that needs to be unique to you. I don't want to see identical labs. All right. Question?
Do we have to tell them like what safety precautions they need, like goggles or gloves?
Yep. Yeah, I said like one of the first things you want to say when you go in there is grab safety goggles.
No, for the procedure. Do we have to?
Yes. Yeah. Yeah. You want to be including the safety procedures in your procedure.
Is there gloves?
I think we've got some more gloves. If you really want them, I can provide them.
Okay, I
Yeah.
didn't know if just gloves need to be in our procedure.
If you feel that's important, you would certainly not lose marks for writing it. You would also not lose marks if you didn't say to wear gloves. Okay. Any other questions? Okay. Get to work, guys. If there's questions, let me know.